So my goal today is kind of threefold. Number one, it's to take any questions you guys have on estimation. I asked you to do a few of these, not all of them, a few of them. Then I want to do some more estimations, but I want to fuse estimation with statistics a little bit and show you how to estimate when you have no idea what the answer is, or even how to start estimation by doing something called simulations. So you've done this before. You've done this before without even realizing. If you've ever tried to like make pancakes from scratch and can't find a recipe, you're like, well, I know it's got flour. I think it's got an egg. And you start like kind of messing around. You're like, oh, it needs some more of this. Oh, it needs some more of this. And you eventually come to something that resembles pancakes-ish. But the idea is experimenting and simulating until you get to a desired result. We'll get into that after we take these first bunch of questions. And then whatever time we have left, I want to introduce the next idea, which I like to call grade, G-R-A-D-E, which is not like your grade in the class, but it's mathematical grade. Well, I guess that is mathematical. A more geometric grade than an algebraic or arithmetic grade. So, what in here gave you grief? And good! This is Tori. That's Kirsten. Where's Tori? Damn it, Tori's not here. That's Kirsten.
Oh, I have a big problem.
Okay.
With creating my own equations. So
When you say equations, you mean just assumptions?
Or making my own equations to solve the problem.
Let me answer that in twofold ways. Number one, first of all, please, and I hope I made this evidently clear in here, you don't have to match my answers. I put my solutions down only to show you how I estimated. You might not agree with me at all. You might go your own route. What I am most interested in, oh, and somebody remind me, I have stuff to give back to you, including your quizzes from class on Monday. I got them all graded. I sent them out to you. Yesterday in a progress report, if you checked your email, you got a progress report from me. I emailed them out. I'm going to try to do that once a week. And in there, you have 2 grades so far. You've got a quiz from last week, which I have here finally, and a quiz from Monday, which I have here as well. I'll get them all back to you. And I got to tell you, I was tickled. You guys did a fantastic job on those quizzes. Most of you got 10s. Almost everybody got 10s. The only ones that didn't get 10s were ones that didn't explain to me what they were doing. Like I see a bunch of numbers and equations that aren't connected. I want to hear your process. So Kirsten, when you say you don't know which equations to use, you could always ask me for an equation. Like, I need to know what the volume of this is, or the area of this is. Start with that. Or I forget what the area of a circle is, or even what shape this should be. I want to know what your process is.
Not formulas, right? Making an equation to solve for B or whatever. That's my problem.
Well, believe it or not, your first project should help you with that, which is due next week, which is all about formulas and solving for variables.
I know, that's what I'm talking about.
Okay.
No, that's what I'm talking about.
That's not what you're talking about.
This is what I'm talking about.
This is what you're talking about.
You have to make your own equations for a lot.
Sometimes you do. Sometimes you do. A lot of what I did in this was just numerical multiplications. Pick one. Let's pick one. Which one was your least favorite of the batch?
Well, the one about the peanut butter jar.
The peanut butter jars in the Grand Canyon. You didn't like that one.
I ignored it because it was ridiculous.
You ignored it because it was ridiculous. We ignored it. That's this one. How many jars of peanut butter would fit in the Grand Canyon?
But let's do the
Let's
do the Lego.
I told you not to do those.
Oh, I like that one.
Well, that's good. I think you'll like it even more after today. I told you to skip E4 and E5 because there was something I wanted to do in class we didn't get to last time, which will help you do E4 and E5. Did you use the program I gave you by any chance?
No, I couldn't figure it out.
Well, then because I didn't explain it to you yet. That's the whole point of the day, was to get you to roll dice and do the pro. So can we hold off on this one? And also, I'll say this now, I'll write it again in the homework sheet. I'm going to add some parts A and B to this. I was right up the hill today thinking about these problems. And that's because that's what twisted people do when they write the blanks. And I thought of some neat little twists I could add to them. So don't do these until later on tonight at the earliest, which I'm sure most of you are going to do anyway. So don't hit these, or at least if you do go back and look at them again, I'm going to add a couple parts under this. So Kirsten, ignore Lego for a second just because I think it's great. And I agree with you, they're some of the more fun ones to do.
It doesn't matter, I tried all of them.
So, okay, who has the least favorite, or one that made him the sickest? Shelly, right?
Yes.
Shelly.
It was the cell phone, the kid in the cell phone.
The kid in the cell phone, okay. Let's look at the kid in the cell phone. Here he is. Car dealer offers, and I pasted my solution in for you guys to analyze, and you can say to hell with that. Okay, so read this. If you didn't get a chance to read this yet, this came by on my Facebook page from a buddy of mine in Ohio. A little bit bigger for you so you can read it. Nope. Nope. There it is. Yeah, control. It's like shift or alt or control. There we go.
I'm in the wrong class.
And I read your notes.
That's okay.
10 times.
Don't worry about it. Hey, we're gonna figure it out right now.
Okay.
Here's the deal. Here's the deal. The story behind this, if you didn't read this yet, the story behind this is some kid was screwing around on his iPhone in a math class, and the teacher saw him screw around the iPhone, took the iPhone away, reset the password of the iPhone to be the solution to that problem, and then gave him the phone back.
Awesome.
That's ballsy. That's a lawsuit waiting to happen.
Oh, yeah.
That is in this day and age, it's a lawsuit waiting to happen. I also think it's brilliant. But I'd rather, so this is, and this is interesting, it's a discussion me and my colleagues have all the time. We just had this lengthy discussion last Friday about cell phone technology in math classes and what we're gonna do about it. And I said, what do you mean we're gonna do about it? They're like, well, how do we get to turn the internet off? I'm like, let them leave it on. Like, what do you mean? How do you know they're gonna cheat? I said, well, like what you're calling cheating, I'm calling collaboration and using resources. And it's like, it was so funny coming from a statistical point of view versus an algebraic point of view, because they have a point. If you're teaching somebody how to like add fractions, and you're testing somebody on how to add fractions, you don't want them to have internet resources on an assessment, because you want to see if they can add 1/2 plus 1/3 to get 5/6. But for statistics, I'm like, good Lord, go out and get it. Go out and get the data. I mean, if the data's out there, I mean, the assessment should be reflective of what your resources are. And for statistics, I mean, my good, this stuff is wonderful. It's out there. That Grand Canyon problem, for example, you gotta know how big the Grand Canyon is, first of all. How many of you Googled it? Yeah, good! Go figure out how big the Grand Canyon is first, and then figure out how big a peanut butter jar is, and then do some division. I mean, that's what I want you to do. I don't want you to plot. I don't want you to like, okay, the Grand Canyon is at least as big as my house. How many houses? You know, that's what I don't want you doing. I can't envision how big the Grand. It's too vast. It's one of those things you see from space, right? Okay.
So estimating isn't quick.
Not necessarily. Not necessarily. It can be. It can be depending on the type of problem. Now, the thing about this problem, who asked for this? This was the right one to ask for. Shelley, was this you? The thing about this one is great. You can actually ignore all of this, because this tells you quite a bit of what's actually going on. He says, monthly payment rounded to the nearest dollar. First number is 0. Now, something you may have had to Google if you're not familiar with an iPhone is, there are 4 numbers in the passcode. He's told you the first number is 0, or she, whoever this is. That means you have to find 3 numbers. What I say, and I make a mention of this in the solution, is assuming there's no lockout to the phone, just start at 0000 and keep going until you crack it. How long would that take? That's what I was getting at. How long would that take? This same thing happened to me years ago. Years ago, a friend of mine had one of those little pocket organizers. I mean, one of those little tiny, like, keep your ad. Before we had cell phones and wireless technology, it was the rage, or the little digital organizers. You put your friends' numbers in. It took you like 3.5 hours to enter a number, and you were like, I'm so badass. And it had a 2-digit password. 2-digit password. That's all it was, 2 digits. And he's like, oh, dude, Rule, I lost my password to this. And I was like, oh, let me see, I'll see if I can crack it. And I started cracking. He's like, oh, are you doing some of that crazy math stuff? And I'm like, no, I started at 00 and I'm going up to 99. He's like, oh my God, you're never going to find, and then I handed it to him, cracked. Because with 2 digits, how many possibilities are there? 100, actually, from 00 to 99. And you can figure that out. Let's figure that out. Let's figure that out, why it's 100. It seems like 99, but you got to count 00 as the first possibility. Does that make sense? Right. So if there was only 1 digit, and you should have said, I wish you could have seen his face too. You're never going to find it. How'd you do that? I'm like, well, I have fast thumbs. I mean, that's really the only thing is fast thumbs. So my point with this problem and that problem is, you can figure out how many options there have to be. Suppose there was only 1 digit that you could use in a password, which would be the worst password on earth, right? How many possibilities?
10.
10, 0 through 9. If there were 2, we just solved that problem, didn't we? There's going to be 100. And what's interesting about that, we're going to come back to this in this class, but that's 10 times 10. And think about why it's 10 times 10. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. See, you can almost envision a tree branching out. Suppose there are 3 digits. There's going to be 1,000, aren't there? That's part of the solution to our problem, isn't it? Because we know the first one is 0. The last 3 digits only have 1,000 possible permutations from 000 to 999. So I say to hell with this. You can figure it out if you want to. And I think in my solution I made reference to that where I actually started crunching the math, and then I said, or you could just simply run through it and try them all from 000 to 001 and so forth and so on. So let's swing over to this side of the board and do some work, shall we? Yes, you will learn to think differently in this class, my friends. I know. It's thrilling. We can also run the math if you want to, because I did it both ways in my solution that I posted for you guys. I basically posted the solution that I sent back to my friend Jerry in Ohio as Facebook replies. And I posted twice because when I realized that once I was posting the first one, there isn't enough information to answer the question. There are certain things that need to be kind of clarified. And then I said, hell with it, let's just start guessing at them until we get it. So, let's figure it out. Number of possible passcodes. And this does, please realize, this does require that you know an iPhone has a 4-digit passcode. You have to know that. But does anybody have a non-iPhone with a passcode? Is it 4 digits as well? Yeah. And is it 4 digits? Yeah. It's digits, and Hassani's digits, and this is, wait, this is, what? No. Cameron. No, Cameron's over here. Say again?
David's not here.
David! Yeah. And David's over here too. Yes, yeah. Or Ryan. Ryan, David, Hassani. I don't see Cameron. We're getting there. That's Kirsten now. Anyway, so you have to know something about the passcodes. They go like this: boom, 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 boom. There's 4 places to fill. Now, if we didn't know what this one was, if the teacher didn't say that the first one was a 0, how many possibilities would there be? There'd be 10,000 every single time you add a digit to the passcode. It becomes 10 times more difficult to crack it. Have you noticed over time, you guys might not have because you're, well, maybe you have, passwords, they keep requiring passwords to get longer and more sophisticated. This is the reason. When I started my Hotmail account back in 1990, whatever the hell it was, my password was 4 digits. That's all they required was a 4-digit password, like this. 10,000 possibilities. You know how long it would take a computer to crack that?
A minute.
Less than a second. Less than a second. Maybe back in the 90s it was a minute.
Yeah.
But nowadays, less than a second. Have you looked at the password requirements on your COCC Bobcat Web password?
They keep messing.
Between 6 and 15 characters. Letters, uppercase, lowercase, distinct, and digits. So, you've got trillions upon trillions upon trillions of possibilities now. You know how long it would take a computer to crack that? A couple 10,000 years. Years! Remember how big a trillion is. Remember how big a trillion is. And we're talking about trillions of trillions of trillions. Don't ignore that. Trillions of trillions. Supercomputers are fast. They can do billions of computations a second, if not hundreds of billions computed. But there's a lot of 100 billions in trillions of trillions of trillions. That's kind of fun. What did I just say? What did I just say? I'm glad I recorded it. But anyway, the point is, that's the reason they keep getting longer and longer and longer. So they want to lock you out. They want to make sure that you're secure. If your personal information's in there, they want to keep that secure. And I thanked Jessie. I thanked the head of the Banner Bobcat Web. And I sent her my math. And I was like, thank you for doing this. And she sent me back this exclamation point. She's like, what the hell are you talking about? Like, the math didn't make sense. But she knew intuitively that the more complex they make the login and the password, the less likely it is for you to get into it by guessing. Because that's what we're talking about here, is forget the math, let's just guess. Okay, so we know this has to be a 0. So these have 1,000 possible permutations. I'm going to keep using that word through class if it's okay with you guys. Possible permutations. And I'll list a few of them. It starts with 000, and then 001, and then 002, and you just try them all until you get to 999. And you got to remember that that 0 is before all of those. So it's 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2. It's hard to say. 0, 9, 9, 9. That's easy. Say that again. That's not. Well, but that's the thing. That's why he put the 0 in there. And based on this money, and this is what you'll see in my first solution, when you crunch this, if you ignore some of the percentage things and just go with the raw number of the $21,000 or $20,000, and you break it down, it ends up being in the hundreds, which is what he's getting at with this. By putting a 0 first, that means your car payment's in the hundreds per month. Now, granted, a $999 car payment is not likely, but if you don't feel like doing the math, realize what he gave you right here. Isn't that amazing? What he gave you in this last sentence is actually, he saved you 10 times work, didn't he? Or she. I keep saying he. Seems like only a guy would be ballsy enough to pull this off. A woman would be like, just don't play with your phone in class, please. Please, be reasonable, learn. You're spending your own money being here. The guy's like, dude, that just seems like something a guy would do. So if you put the 0 in there, he or she saves you, he takes 1/10 of the work and basically makes your work 1/10 of what it was. Because he's telling you the first number. Does that make sense? Think about it. It goes from 10,000 possibilities to 1,000 possibilities. That's 1/10. Fair? Good. All right. Now, how long would that take us? Here's where the estimation comes in. This is actually a calculation. This isn't an estimation yet. This is a calculation. Estimate how long it would take you to do that. Ballpark. Let's ballpark it right now. Then we'll do some quick calculations. Tell me your name one more time. Diane asked me a great question earlier. Is this stuff by the seat of the pants, or is it take time? I like to compare and contrast. I want to use a little bit of calculation on this for sure. But the first thing I want to know is how long do you guys think it would take to run through 1,000 of those? Give me some ideas right now. 10 minutes. We got a 10 minute? An hour. About an hour, 2 hours. 2 hours, 10 minutes, an hour.
A day.
A day.
30 minutes.
30 minutes.
2 hours.
2 hours. Good. This is quite varied actually, from 10 minutes to a day. Now, those are some assumptions. I only heard from a few of you though. It's okay. That's okay. Some of you have ideas in your head you don't want to share. That's okay too. Now let's make some assumptions. Everybody, take your hand. If you have a phone, you want to use your phone. And just imagine holding a cell phone in your hand and typing 0000 enter. Okay? So go through the motion 0000 enter. So now you're testing. You have to type that first 0 because you have to actually, you know what it is. So you have to use it, okay? Now once you've done that a few times, look up the clock and time yourself doing it. Got a rough estimate of how long it takes? What do you got? What do you got? Micah?
About 4 seconds.
4 seconds, good. 4 seconds? 4 seconds, good. 4 seconds, maybe 3. Depending on, some of you are 4, 3, Andrew's saying 4. 3. So between 3 and 4? 2. Size like I can do it in 1. If I name that tune.
A saxophone player.
Saxophone player, you got it, man. You got it. You're on it. I'm a drummer. I'm like hitting the wrong notes. Now, the question is, how long would it take you to do that? Hit enter, watch the screen say wrong, and then be ready to start again. What do you think? Because chances are, unless you're like me, your passcode wouldn't be 0000. I'm running out of Spaceballs right now. Password idiot puts on his luggage. 1, 2, 3, 4, 5, right? So how long would it take you to go 0000 enter, and then you're like, ah crap, it's wrong, and then try
5 seconds.
5 seconds? You like 5 seconds? Like 5 seconds? Wait,
Or
tell me your name.
Kristen.
Kristen? So we got Kirsten, we got Kristen. Okay, good, good. So we got 4 seconds, 5 seconds. Anybody else want to throw in? Do you want to overestimate at 10? We can do it a couple different ways. But the fact of the matter is, do you see where I'm going with this? If you know how long it takes you to check one code, press enter, and register the result, what do you have to do with that number?
Multiply it by 1,000.
Multiply it by 1,000, where that number, there it is, and that gives you how many seconds it's going to take you, at worst, to crack the phone, assuming you start at 000 and it's actually 999. Shall we?
Yeah.
Yes.
I'm going to use 5 only because it's easier to multiply and divide with that when we're done, I think. But you can use 10, you can use 5, you can use 4. I'm going to assume, there comes the estimation. I'm going to assume it takes 5 seconds to test a passcode. Hit enter, or whatever you have to hit. You have to hit enter? I don't think you do anymore, do you? I think you just type the numbers in and it defaults to enter, and then it lets you know if you're right or wrong. Hit enter, and then verify. And I'm assuming, and I don't know the answer to this, I'm assuming you can keep going until you get it right. I don't think it locks you out. I don't think. Okay? That's a big assumption, by the way, isn't it?
It is.
Oh, it does lock you out.
After like 5 times.
5 times. Ooh, we'll have to adjust our estimate for that. Hang tight. We'll have to adjust our estimate for that. How long do you have to wait until you try it again then?
It just depends.
My phone's set at 15 minutes.
15? Oh, let's ignore that and then come back to that. No, this is good. This is a realistic check. Let's ignore that and then come back in and factor it in, shall we? Okay, let's say we keep testing ad nauseum until we find it. So it's going to take 5 seconds to test the passcode. That means we have 5 seconds. This is some unit analysis right here. Times 1,000 possible passwords or passcodes is 5,000 seconds. Now, of course, you are testing every single passcode with this assumption. That means it actually was 999. Chances are you landed somewhere in the middle. On average, if it's a randomly generated number, it's going to be closer to the middle than on the ends. But we don't know that because of the money. We'll come back to that point too. Okay, 5,000 seconds is how long? There you go. Divide that by 60. Divide that by 60 and you got minutes. If we made it 6,000, if we made it 6 seconds instead of 5, it'd be even easier. We have 6,000 divided by 60, which would be a whopping... Go ahead. Oh my God, math first thing in the morning. It's terrible, isn't it?
It's 100 minutes.
There you go! It's just short of 2 hours. Just short of 2 hours. There we go. Somebody actually guessed 2 hours, didn't you? I thought I heard 2 hours come up here. I heard 10 minutes. I heard... And this is all dependent on how fast you can... You know. A supercomputer does this in less than a second. We're not a supercomputer. We are much better computers. We can think for ourselves. Fair enough? So it would take you about 2 hours to crack your code at worst. It would actually, on average, take you closer to 1 because your answer would probably be more close to the actual middle of the data set than the end, either end. So on average, take you about an hour. But we can go with 2 hours. Worst case scenario. Now, here's the problem. Here's the problem. The problem, of course, exists that you can't keep going willy-nilly because it's going to lock you out if you stop. So one thing you could do is study your phone, and if you know it's got 5 until it locks you out, do 4 and then wait a while. Then do 4 more and then wait a while. Or just do 5 and wait, and that depends on which is longer. How long do you have to wait before trying again? If it's longer than 15 minutes, then do that. Or then don't do that, then just get locked out. So let's assume this assumes no lockout. That assumes no lockout. So let's time out right now. Is that okay? Do you see how that's an estimation? Do you see how some of it's a calculation? Some of it's a calculation, figuring out how many passcodes there were. But you guys can figure that out. We'll figure out more of it today when we roll some dice and flip some coins. We'll do that as well. But as far as the estimation, where did the estimation happen, friends? Where did the estimation happen? Right, the assumptions you make. That's why I asked you to state them. State your assumptions. I'm going to tell you right now, your quiz for next week, I want to ask you to estimate how many emails COCC gets between noon and 1 on any given workday. That's it. And I don't care what your number answer is. Because, God, I don't know what that answer is. What I'm going to do is I'm going to check, see what you guys write down. What did you assume? I'm going to give you hints on the quiz. I'm going to say things to think about. Just things that I would think about if I was estimating that kind of thing. Okay? So I'll give you a little, think about this, maybe consider this. But I'm interested in your process. I'm interested more in your process than what number you get. If I want the actual answer, I can just go call Cindy Jeffries. And be like, dude, how many emails did we get today? Today's Wednesday. Yeah, today's Wednesday. But I don't want that. I want you to think about it. And then I'll call Cindy Jeffries and ask her, and we'll talk about it next week. We'll see how close our estimates were. Fair? Okay. Anyway, back to this. I'm happy with this because I did the same thing. I assumed you no lockout, but if there is a lockout every 5.
Last you 6 times, and you get 2 minutes.
2 minutes between. Okay, let's make it 5 just because the number's easier. Yeah, let's make it 5 because 6 doesn't divide into 1,000 easy, but 5 does. Yeah, and it might be different from phone to phone. So let's assume a 5-minute lockout period, or 2-minute lockout period, excuse me, every 5 tries. Does everybody hear that? And tell me your name one more time. Brittany. We got 2 Brittany's. Okay, good, Brittany. So we get locked out 2 minutes every 5 erroneous tries. So worst case scenario, how many times do we get locked out? Worst case scenario, How many times do we get locked out? Good, I like that over there. I'm gonna slide over to this board. I think it makes more sense. Back it out. Oops, that's in. Yeah, it would, wouldn't it? Yeah, well, technically 199, I guess, because you wouldn't ever get to the 200th one. Because if you got 199 lockouts, you only have 5 numbers left, and it's got to be in that 5. But let's call it 200. What the hell, the math's easier, right? Estimate. Estimate, which kind of goes hand in hand with approximating. So yeah, let's go with 200. Do you guys see how they're getting 200 lockouts? If you have 1,000 numbers you're trying, 1,000 numbers you're trying, every 5, there's 200 sets of 5, from 0000 to 0004, and then 0005 to 0009, and then whatever's next, 0010. You see what I'm getting at? So there's going to be 200, 199, but we'll call it 200. So assuming a lockout every 5 erroneous numbers, thank you, Ariel, erroneous guesses. There's an extra U in there. Erroneous guesses. For 2 minutes. That means we have 200 lockouts that we may have to deal with. We're talking about worst case scenario. Probably on average 100. But 200 lockouts. Each of those is 2 minutes. So that's 400 minutes. There you go, of downtime, which is about 6.5 hours. So you better add that onto the 2 hours over there. It's going to take about 8.5 hours to get back into your phone. Worst case scenario. Worst case scenario. More like 4-ish. And at that point, you might say to yourself, is that worth it? Or should I actually just solve the damn problem? I can't answer that for you. That's up to you. You can probably get closer. I made reference to this in my solution. You can get closer to the solution by just doing a little bit of the math. You can ignore quite a bit of what's going on. Like, you can look at the fact that it's a $22,000 car-ish. And they want, he's got 600 and 500, which is about 1,000. Take 1,000 off, make it 20,000. The finance company insists on $10 deposit down for a 22% flat rate deal. So now what you can do is take the 10% off, because he's putting it down, assuming he has it, then figure out the 22% APR on the $20,000 and figure out you can get closer to where it is. But some of you might say, that would take me 4 hours right there to figure that out. In which case you just start brute forcing it. This is valid, just so you know, and this is one of the grand crimes, I think, of algebra classes, is algebra classes make you think you have to solve that down to the nearest dollar. Computers don't do that. Computers use brute force in a lot of ways. Your TI calculator you're holding in your hand, remember in 95 when you found intersections of lines? You probably did it on this quiz, where you had to, well, you didn't use your TI, you used the graph, but you would type a line, the line, they would intersect to find that point, and you'd use the second calc 5, intersect, curve 1, curve 2, guess, and it would find it. Is the calculator doing the same thing you do? When you would do that, you'd set an equation up. You'd say, like, you know, x plus 3 over 2 equals x squared minus 2. You know what the calculator's doing? Here's your 2 curves intersecting. Here's what your calculators are doing. This is news to most people, most math students. It's very quickly, this is what computers are designed to do. Computers, believe it or not, computers are not designed to check Facebook accounts. They're designed to do stuff like this. It's picking given x values. That's why it asks you for a guess. The guess gets it close to where it needs to be. It takes a given x value and tests the y values at that given x value. So it says, okay, there's one, there's one. Blue marker's dead. There's one, there's one. There's one, there's one. Are they equal? No. There's one, there's one. Are they equal? No, but they're closer. So maybe we're heading in the right direction. There's one, there's one. Equal? There's one, there's one. Equal. There's one, there's one. Equal. And eventually, you get down to a spot that is close enough. And when I say close enough, do you remember in 95 sometimes? 95 sometimes you'd get a goofy answer. We're supposed to be 0. But it wasn't 0, it was like -1 times 10 to the -21st or something like that. Because the machine is approximating. It's not solving, it's approximating. It's doing basically brute force calculations very, very, very quickly. That's what it's doing. It's not it's using calculus approximations. If you take calculus classes eventually, which I don't think any of you are going to do, that's okay. That's what it's doing. It's doing calculus on your curves. You solve them by hand, it solves using calculus very, very quickly. But I didn't come here to tell you that. I didn't. I came here to take your questions on stuff like this. So, what's the big takeaway? Do I care about the number you get at the end? In estimations. Do I care about the number you get at the end, Micah?
You're more interested in the methodology?
That's what I want. Because when you guys go into your jobs, you're going to have to do stuff like this, like financial planning. I'm doing it right now for Bend Film. I designed a survey for Bend Film that I will go down starting tomorrow night and making sure it all works online. Because I want to find out who their constituency is that comes to Bend Film, because I want them to get more people to come out to it. The only way I can know that is by knowing who comes to Bend Film and how we can target them better. And the only way I can know that, because I know jack about Bend Film, is to conduct a survey, collect some data, and take a look, which we'll do after the break. Because there's some times when you have no idea where to start, which I think the experiments I have today will show us that. We have no idea where to start. Yeah? So I don't care what answer you get, which I know is a very strange thing to hear in math class. Very strange thing to hear. I care about your process, yes? That's what I care about. All right, you get that glazed look. Go take a walk, get some air, come back. Yes.